And now let's just get to our notes. Okay, here's what I want you to take away from today. Sine and cosine are periodic functions. Periodic means that they are repeating. They are cyclical. They go in a cycle because that's the way that the circle works. And they repeat every 2 pi, as we discussed before. Now, we graphed these basic functions, sine and cosine. Remember what we said about sine? It's a wave. It starts at 0, 0, and then it waves up and then down. So if we had to like describe it. Whereas cosine, it's more like a U graph. It starts at 0, 1 is the starting point instead of the origin. So cosine starts at 1 and then it dips down and then meets back up at 1 again. So that's cosine. Take a minute and just memorize these graphs. So the one that starts at 0, 0, is that sine or cosine? The one that starts at 0, 0 is sine, and then it waves up and down. The one that starts at 1, 0, the U graph, which one is that? The U graph would be cosine, and it dips down and goes back up, okay? So just know the general shapes of the graphs. These are very, very important in our future lessons. Now we graphed the very, very basic functions without any numbers in front or on the side. But once we start shifting, as we will in today's lesson, we may see a number outside in front. We will call that A. We can see a number in front of our X or in front of our theta, and we call that B. Or we can see a number being added at the end, we'll call that C. And what we're going to discuss now what each of these does. So if you see a number, that is being multiplied in front, our A, we call that our amplitude. And the amplitude is just, the definition of the amplitude is the height of the graph from the midline. So if this is our midline, right, this is our midline here, the height of the graph from the midline, you can see that it's 1. It goes up 1 and it goes down 1. So the height of the graph from the midline here, the amplitude equals 1. Same with our cosine graph. From the midline, our graph goes up 1 and it goes down 1. So in both cases, we have an amplitude of 1. Okay. If we have a negative A, it's going to flip our graph. Just like always, when you have a negative in front, it'll flip the graph. So if I had a negative in front of my sine x, my graph would look like this. My amplitude would still be 1 because it's still going up 1 and down 1. But we just know that it would flip the graph upside down. So if we had a negative cosine x, the graph would look like this. Instead of starting up at 0, 1, it would start at 0, negative 1, and it would be flipped upside down. That's how negatives affect our graph. Okay, we won't graph any of those today, but just good to know. So that's what an amplitude is. It's the height. Amplitude is the height. Next, what's the number after sine but in front of the x, or after cosine but in front of the x? What does that do? Well, that b there affects the period of the graph. So the period of the graph is given by this equation. 2 pi over b gives us the period of the graph, or the length of one cycle. So it's how long it takes for this graph to end at its same starting point. And you can see that for both sine and cosine, the period, the length to repeat, is 2 pi. So for our examples today, we'll always do 2 pi over b. Now notice here my b is 1 because there's nothing in front of x. There's nothing in front of x, so that's why my period in both of these cases is 2 pi over 1. So for today, you don't have to worry about the period shifting at all. Okay, so since there's nothing in front of the x, our period is just going to be 2 pi over b, which is 1. So our period is 2 pi. Same here. our period was 2 pi over nothing in front of the x, that's 1. Hence, it repeats every 2 pi. And then finally, that plus c at the end represents our vertical shift, or how far the graph is moved up or down. So the number of units the graph is shifted up or down from its normal starting point. So since we don't have anything in these two examples at the end being added or subtracted at the end, the vertical shift is 0. See? Plus 0, plus 0. So we'll say our vertical shift equals 0 in both cases. So that's our vocabulary. These are our basic graphs, our parent graphs. Now let's see what happens when we actually play around with those numbers.